Okay, recording started. Thank you.
Okay, great. So starting, welcome. Thank you for joining me on my presentation. I'm Szymon Krasuski and I work at Codilime. I participated in two projects connected with Tungsten Fabric. One was connected more with cloud infrastructure, and another one was connected more with operatorizing deployment of Tungsten Fabric. And today I want to briefly talk through all the components of architecture of Tungsten Fabric. So hopefully at the end of this presentation, you'll know how Tungsten Fabric works on this high-level structure, and you'll have some knowledge how it should be organized and how you may deploy it with your environment or your system that you want to deploy Tungsten Fabric. So starting maybe with some history, because you may think that Tungsten Fabric is a pretty young product, because from 2018 there was a Tungsten Fabric name created when Tungsten Fabric joined the Linux Foundation. However, starting in March 2012, there was a startup called Contrail Systems that created the first version of a product that we know today called Contrail. And then in December 2012, Juniper Networks bought this startup and started developing Contrail on their own. And in 2013, Juniper released most part of the code under the name of OpenContrail, which was the open source and was developed still by Juniper Networks. And then OpenContrail transformed into Tungsten Fabric under Linux Foundation, and this is the product that we know today. So this is a pretty long history with this product. So the history developed a lot of solutions for Tungsten Fabric. So Tungsten Fabric supports a lot of use cases, mainly because it looks only for API. So when you have a Tungsten Fabric, it communicates via API. So on the other end, when we have no matter whether virtual machines, whether containers, bare metal servers, or any other technology, as long as it fulfills the API needs, Tungsten Fabric may be used. So when we have solutions with Tungsten Fabric, we have a whole set of solutions starting with orchestrators and virtualization platforms. So personally, I worked with Kubernetes and OpenShift. With Tungsten Fabric supports OpenStack, SmartNIC devices, SRIOV clusters, cloud platforms. Personally, I worked with all the free clouds that are listed here, and some third-party solutions developed by other companies or for special use cases. So when we think about the Tungsten Fabric, we may think about it as modules, some Lego blocks that we may connect together in order to make the whole infrastructure that suits our needs. So we'll talk through all these blocks, and you'll see how you may connect these blocks to make the system that connect all the functionalities. No matter whether you have physical devices or you have a Kubernetes cluster or you have an OpenStack cluster, you may connect them together under one system, Tungsten Fabric. And when we want to talk about the architecture of Tungsten Fabric, we may split it into two categories. We have the control plane and data plane. Control plane is, in fact, the core of Tungsten Fabric. This is the part that provides the functionality of Tungsten Fabric. Because simply in simple words, Tungsten Fabric allows us to manage network easily. So when we want to allow some traffic, deny some traffic, or when we want to isolate some network, we may define that in Tungsten Fabric, and then Tungsten Fabric spreads that information, that rules across our infrastructure, and we may isolate some networks or do whatever we want. So in control plane, we have a config, control analytics, and under config, I wrote two small components that are in config, Kube Manager and Device Manager. We'll talk about that. And in data plane, we have vRouter. So this is mainly what we will be talking about today. And starting with the first component, this is the biggest component. It has the most number of lines of code. And probably this is the biggest part of Tungsten Fabric, and the most developers work under this component. And this is the brain of the platform. And when we want to think about the Tungsten Fabric config, when we think about the database, we have a database with some configs, and we write their configs and read that configs. So when we have a user defines the rules for our network that we want to apply to our infrastructure. So this is the part that writes the configs, and then we have our infrastructure that applies these rules. So in fact, reads the configs from this database. So we will take a look at this schema of Tungsten Fabric config with Kubernetes. Today I'll present you the schemas for use cases with Kubernetes, because this is the part that know well, and I'll talk about some small differences with Kubernetes. So in the center of our Tungsten Fabric config, we have database. This is the Cassandra database supported by RabbitMQ and Zookeeper. And Cassandra is a database that has a pretty quick write functionalities. So we can write a lot of data quickly into Cassandra. But reading from Cassandra is not so quick, but from my experience, it's enough to support the Tungsten Fabric functionalities and features. So we have a database that we put configs there. And let's take a look how user may put the configs there. So we have a system admin, some person that wants to put config some rules into our infrastructure for our network. So he can log in into web UI. And web UI is a nice UI. You may open that in web browser. That has all the components that you see the status of your infrastructure, or you may create some rules there. So generally our system admin, for example, wants to isolate the network. So he puts the rule to isolate some network in our infrastructure, and web UI transforms this into request to config API. So config API is API that accepts the request and then computes what object it should put into the database. So it puts the object that this network is isolated. And then we have in our database defined config. However, this is not the only way of putting our object into database, because when we have a config API, this is the normal regular API. So we may use the web UI, but we also may use the standard HTTP request that we may make with curl, or we may use the Tungsten Fabric CLI, which is a nice CLI to just easily write the request. So this may be useful when we want to create some automation process or integrate Tungsten Fabric with some other tools or systems. But then we have our object in database, and generally Tungsten Fabric is intent-based. So it means that when we have an object, for example, we define that we want to isolate some network. This is not the only thing that has to be created in database. We need to create some firewall rules, some routing rules, and a lot of other things. So generally, user does not do that. There's a scheme transformer part. This is the part that observes the database. So when there's an event of writing data into a database, scheme transformers reads that and then computes what other objects should be added to the database in order to fulfill the rules that customer wants to apply, and then makes a request to config API, and config API again computes the object that it should put into the database and puts it into a database. So this is pretty much how the core of Tungsten Fabric config works. But also we have other elements here as well, as you can see. So for example, we have a device manager, and device manager is an element of Tungsten Fabric config connected with physical devices. So when we have physical routers, physical switches, we use device manager. And generally, it takes the request from database and config API and computes it into some rules applied to the physical devices. So device manager has 4 functionalities. So the first one is the device manager, which in fact, as a schema transformer, takes the high-level definitions that should be applied into physical devices, and then computes the specific configuration that should be applied to these devices. There's also a device job manager, which in fact is a set of playbooks written in Ansible for Ansible. And then these jobs are applied into physical devices in order to provision them. We also have a DHCP server, which is the server that may work alongside device manager to provide the IP addresses. But as far as I know, it's not compulsory to use this DHCP server. We may have some other server. But this is a nice feature for device manager and physical devices. And we also have a TFTP server, which also works alongside device manager and may provide init config scripts for physical devices. So when the device is booting up, it may now load these scripts and configure to the scripts presented into this server. Okay, and there's also another element connected with Kubernetes, Kube Manager. And when we have a Kubernetes, and for example, we apply some annotations, because in Kubernetes, you may, for example, define for namespace annotation that defines that its namespace should be isolated. Or when we use Tungsten Fabric as CNI plugin and we create the new pod, then we request the new IP. The Kube Manager observes the cluster and then reports what was created in this cluster to config API. So in that way, we may simply use the kubectl to add the annotation to isolate the namespace, and Kube Manager will observe that and create the proper request to config API. And config API will create the object into database. Yeah. And generally, that's how the Tungsten Fabric config works on a high level. And then there's the part of Tungsten Fabric control. And this is the component that interacts between the devices in our infrastructure, compute nodes in our infrastructure, and the config, the database with configs. And this is the one that provides the control over the infrastructure. So when we think about the Tungsten Fabric control, it uses the ifmap protocol to take out the configs from database and pass them into our endpoint, our end devices, no matter whether it is container, a virtual machine, or bare metal server. And it looks like that. And you may notice that we have two components, controller and control node manager. So in config, probably also saw that we have control node manager. So for now, we will omit that, because at the end there's another component that uses this node manager elements. So in controller, in fact, we have only one element called controller. So it reads configs from Tungsten Fabric config from the Cassandra database, and also synchronize with other controllers via BGP protocol. So because Tungsten Fabric supports the HA mode, so it means that you may create multiple controllers that will not fail Tungsten Fabric control system when one node will die out of the sudden. And you also may create multiple Tungsten Fabric configs as well. So the synchronizing via BGP protocol is for controllers in order to keep the consistent configuration taken from database, so that all the controllers provide the same routing rules, for example, into our system. So there are no conflicts. So controller puts our configs in two directions, into two places. So the first one is Tungsten Fabric compute. In fact, these are the endpoints, some compute node at the end of our infrastructure, and we put there via XMPP protocol the configuration from database, and then the compute uses the vRouter to apply it properly into our system. But there's also another part that may be interesting, and this is the gateway node devices configured via BGP and netconf. And in fact, these are the gateways. So as a BGP, we provide the routings into these gateways to provide the routing that should be applied in our infrastructure. And it's worth noticing that we need these two elements in order to correctly provide our provision our infrastructure. So we cannot just simply configure the computes or just log in into compute and apply some development configuration. We need also to configure the gateway node devices to have the working infrastructure. So maybe that's useful when you will develop something under the Tungsten Fabric one day. Okay, and the last part in our infrastructure, the working part, is Tungsten Fabric vRouter. And Tungsten Fabric vRouter is, in fact, the component installed on all compute nodes. And we have the vRouter forwarder and agent. And generally, when we have a Tungsten Fabric and we have compute nodes, so these are the machines that have some workload in our infrastructure, we need to have vRouter on every one of them. Because this is the part that takes the configs and then apply them into our machines, our compute nodes. So looking at this scheme, we have Tungsten Fabric control at the top, which via XMPP protocol sends data to vRouter agent. And we here have a vRouter agent and vRouter forwarding plane. So this is the standard part of vRouter, usually that we use for example, bare metal servers. But we also have a Tungsten Fabric Container Network Interface plugin. So this is the CNI plugin, and this is for special use case with Kubernetes when we want to use Tungsten Fabric as CNI plugin. So for example, it means that when we create the new pod, this pod will get the IP address from Tungsten Fabric. So in that case, we use that component and we integrate Tungsten Fabric with CNI. Usually, it means that we put some config file into a specific folder in Kubernetes, and Kubernetes will use Tungsten Fabric usually out of the box. In fact, when we provide the vRouter agent forwarding plane. So starting, we have vRouter agent that receives some data from control, and then it creates a local database with VRFs and ACLs, so virtual routing forwardings, and access control lists. And these are the rules that define how the traffic should be treated. So when we have the database, we have a vRouter forwarding plane, and vRouter forwarding plane is usually synchronized with vRouter agent via casing and shared memory. And vRouter forwarding plane communicates via TAP interface, usually called PKT0. And when we have a vRouter forwarding plane, usually it means that we have a virtual interface called vHost0. And this is an interface that, in fact, hijacks the IP address from some physical interface. So, for example, we have the ATH0 interface, and all the traffic that will get into this interface will be relied into virtual interface vHost0, and then vHost0, based on vRouter forwarding plane, will decide what to do with this traffic, and will send it further, deny it, or allow the traffic, depending on what you want. Yeah, and I was talking about the CNI plugin as well. And when we have vRouter forwarder, so it can allow, deny, or redirect the traffic. And usually how it works is that we have our machine and we apply the kernel module. So kernel module has some pros and cons. So some pros are that it's more efficient. It has a more efficient processing because we're using kernel space instead of user space. We as well have a room for optimization in this module. However, it supports only specific kernel versions because usually it's distributed via the officially released Docker images or just container images, which contain in files a few versions of compiled kernel module for multiple systems. Usually the best supported system is Red Hat. And it's important because sometimes when we have a machine and a kernel version that strongly differ from the kernel modules applied in this container image. For example, I had a problem that I had a CoreOS system. This is a Red Hat 8 based system, and it's pretty new. So there was a kernel version 4.18 point something, and I couldn't apply the officially released kernel module into it because the newest supported kernel module was 3 point something. So I had to manually compile the kernel module, then create my own container image which was based on this officially released image with additional kernel module compiled, and then apply it into my infrastructure, into my system. However, sooner or later, probably these new kernels are supported. So we may wait for officially released containers or just create them by ourselves, which is also some way out of our problems. And also when we have some systems like, for example, Ubuntu, where we can dynamically implement kernel modules for multiple kernel versions, this is easier. And also the con is that we have to use privilege mode on the install. So we need to, for example, when we have a pod that installs the kernel module, needs to be in privileged mode, or at least has some capabilities to install this kernel module, which may be hard. For example, coming back to this example with CoreOS, CoreOS is a system that's in fact read-only, so you cannot install a kernel module on the runtime of this system. You can do that only on the boot of the system. So you need to find some other way to do that. And you may, for example, use the DPDK mode, which works in user space and maybe sometimes some way out from your problems or not, depending of your situation, your environment. Okay, and when we have some traffic, some new traffic that first time comes to our vRouter forwarder, and we don't know what to do with that, then what happens? First of all, with tab interface PKT0, it asks the vRouter agent what to do with these packets, with this traffic that it received. Then vRouter agent checks with VRFs and ACL's database what are the rules that should be applied for this traffic. If there's no information, then it asks control, Tungsten Fabric control for information. And then with prepared response via casing and shared memory, it sends the response to vRouter forwarder, and then vRouter forwarder applies this rule, and usually also remembers how it should treat every new traffic that's the same as the first one. So on the first connection, it may take some time to go through with your traffic. However, then it should work normally and you shouldn't have problems. Okay, and the last component that's may be a bit tricky, because this is the Tungsten Fabric analytics. And in fact, this is not the compulsory component in your infrastructure, in your deployment of Tungsten Fabric. You may even also apply it after installation of Tungsten Fabric as a separate plugin. And it's used for monitoring and log everything that happens in your infrastructure in Tungsten Fabric. So when you have a Tungsten Fabric, it sends to Tungsten Fabric Analytics, object logs, system logs, trait buffers, flow statistics in TF modules, status of TF modules, debugging data. So pretty a lot of things. And generally, when you have a scheme, you have all the components, Tungsten Fabric configs, Tungsten Fabric control, compute, sending data via Sandesh protocol. This is an interesting protocol because this is the protocol invented by Juniper, and this is a protocol that's taken a name from an Indian newspaper that literally means messenger. So it's bringing the messages about the state of our infrastructure. And generally, as you saw, the node manager elements in all the components that I was talking about. So these are the elements that collect the data and send them into into collector of Tungsten Fabric analytics. So every component has this additional component that collects the analytics data. So we also have here the API server that is connected only with Tungsten Fabric config. And this is some specific element because it receives the user visible entities, UVE, via JSON HTTP. And what does this mean? That's user visible entities. So when, for example, user has some nodes, has some networks, has some vRouters in his infrastructure, he would like probably to see the status of these nodes, for example, whether node is running or not. So UVE is information that, for example, node is running. So the things that are reported to user and usually are visible in web UI. So you send this information. And also, when I was talking that Tungsten Fabric Analytics may be used as a separate plugin, it's worth noticing that in web UI, there's a special environment variable that specifies whether we want to use analytics or not, especially for that use of UV data. Because when we don't have analytics, we don't collect the UV data, then we don't know, in fact, the status of our nodes. So then we have two databases. The first one is Cassandra, together with Zookeeper. And I was talking previously, when I was talking about Tungsten Fabric config, that Cassandra writes quickly a lot of data, but reading from Cassandra is not so quick. So we put there statistics, logs, and data flow info. So some data that we may use for debugging. So when we have a running system, we usually have a running system without errors. So it's collecting all the logs, a lot of data from our infrastructure. But then when we have some error, when we have some critical situation with our infrastructure, then we take a professional services engineer and we read the data from Cassandra, which may occur once in a time. So we don't need to read the data from Cassandra so quickly. So here the use of Cassandra is perfect. And also we have another database, Redis database. So Redis database characteristic is that we may write and read data quickly. So we put there UV entries, which in fact may change often, and we want to read them from web UI quickly as well. Also, there's a query engine, which creates a SQL-like request to collect data from both databases. And then this request collects some data from databases and return the response to the user. So it's mainly for creating some batch of data that we want to collect from analytics part. And also, as well, we have a node manager and database node manager for analytics. So one node manager is for collecting data from collector, query engine, API server. And database node manager is for collecting data from Redis and Cassandra. So as well, analytics collects data about itself. So we also may debug analytics when analytics has some errors. Okay, and these are the four main components used in Tungsten Fabric. So you know how it should work. So you may know whether you need to use device manager or kube manager when you have a Kubernetes or some physical devices. So now hopefully you can connect these blocks into one working system, or hopefully when you log into a cluster with running Tungsten Fabric or any other server with Tungsten Fabric, you will know which part and which name means what. And I also want to show you how it's connected into one system. So maybe a brief summary. We have a system admin, which is a person that interacts with Tungsten Fabric config, whether this is the web UI or HTTP request to the API. puts there some config, some rules that he wants to allow, deny, or isolate some network. Then config interacts with control to put the data into our infrastructure. We also have a configuration sent to physical devices via device manager. And then we have Tungsten Fabric Compute, which is the component working on the compute nodes, which receives the data from Contrail and applies them to our infrastructure, to our networking. And we also have analytics that collects the data from all the components. And when we want to think about the more node perspective of Tungsten Fabric, so for example, this is how it may be put into nodes. So usually when we have, for example, Kubernetes cluster, we have some master nodes, some worker nodes. So we may put all three components. So it means that this is the Tungsten Fabric config, control, and analytics part into the master node. We may also put it in HA mode. So when we have, for example, 3 master nodes, we may have 3 replicas of config, control, analytics, which will work in H mode.
哇塞，一会儿下这么多。
Okay, and then we may.
我知道，没听见。
Sorry.
啊
You have a question?
Casey, can you mute
哎呀，别，我马上号子要了，号子要回来说吧。
Because he is disturbing a little bit.
Okay.
Yeah, sorry about that.
Okay, no problem. Okay, and then for example, when we have three replicas of config, then as far as I know, I was working with some problems on Tungsten Fabric config with Cassandra database. And I discovered, for example, the interesting fact that may be interesting for you, that, for example, when you have a Cassandra and you read some data from Cassandras and you have multiple replicas, then I think about at least 2 Cassandras need to accept the data that you read from Cassandra. So in situation when you have, for example, someone that spoofed the Cassandra instance and you have multiple replicas, then the hacker will not fool our system because at least 2 Cassandras will have to approve the message taken from the database. So usually the more replicas we have, the more secure system and higher availability. Okay, and also when we have worker node and master node, and we want, for example, to use Tungsten Fabric as CNI, then we may install vRouter on both master and worker nodes, which will read data from the control on the master node. So as you can see, you may create the cluster that's using Tungsten Fabric for networking, and as well provides infrastructure for deploying the master node, for deploying the Tungsten Fabric. Okay, and that's all from me. And if you have any questions, I may answer them now.
Szymon, thank you for the great detailed presentation.
Yeah, this was a really great architecture overview. I appreciate this.
Thank you. So if you don't have any questions, you may also reach me on our Linux Foundation wiki or Tungsten Fabric wiki, or on Slack. Okay, so thank you.
Thank you very much.
Thank you. Looks like we are ending the session a little bit early. So our next session starts at 8:30 Pacific time. Please reference the schedule. The minutes have been recorded for this particular session. We'll get the slides and the recording posted to the minutes page here in just a little bit. Simon, if you take care of the slides, I'll take care of the recording.
Yeah, of course. I'll put my slides on the wiki page for this presentation.
Excellent. And if there's any other final questions or if you need anything, please reference the Slack channel or reach out to me via email or Shema. And thank you very much, everyone. We'll see you on the next call in about 20 minutes, 22 minutes.
Yes. Thank you very much.
Thank you.
Everyone.